Alright, so this is the second video in our discussion about double angle, half angle, and some difference formulas. This time I'm going to talk about using right triangles to find exact answers of non-friendly angles. In this one, we're never even going to find out what the angle is. So I guess it potentially could be a friendly angle. We just don't even know whether it is or not. So here, for example, you might be given some information like this, where they tell you that tangent of alpha is 3/4 and cotangent of beta is -4/5, and they give you this little extra information about alpha and beta. And you notice this is telling me what quadrant it's in, right? So this is just saying that alpha is in the third quadrant and that beta is in the fourth quadrant. You can see how that tells you that. These are radian measures. So alpha is between pi and 3 pi over 2, that's the third quadrant. Beta is between 3 pi over 2 and 2 pi, that's the fourth quadrant. So then you might be asked a question like, what's the sign of, let's do one we've already done. What's the sign of, say, alpha plus beta? Well, I don't even know what alpha and beta are. I definitely don't know what they are added together. But I do have some information about alpha alone and beta alone. So you can see where, well, maybe you can't see, but hopefully this will help you to see that it might be helpful to use the sum and difference formula to rewrite this as sine of alpha cosine of beta plus cosine of alpha sine of beta. Because I could possibly get some information about what the sine of alpha is, but never what the sine of alpha plus beta is. Because what you're going to do, if you remember we did this earlier in the year, is I can draw a triangle that represents the information that I know about alpha, and I can draw a different triangle that represents the information I know about beta. And so in the alpha triangle, we know that tangent of alpha is 3/4, which means this would have to be 3 and that would have to be 4. And using the Pythagorean theorem, this would have to be 5. Okay? So now, looking at that triangle and knowing that we're in the third quadrant, we could answer all the alpha questions. So, in other words, I'm going to replace each one of these with something, right? So sine of alpha, well, sine is opposite over hypotenuse, so that would be 3/5. And since I'm in the third quadrant, that would be -3/5. Okay? Likewise, cosine of alpha, cosine is adjacent over hypotenuse, so that would be 4/5. But also, again, I'm in the third quadrant, so that means that cosine would be negative also, because both sine and cosine are negative in the third quadrant. And then if we go back to beta, so cotangent is 4/5, so that means that the adjacent is 4 and the opposite is 5, which means the hypotenuse would be, what? The square root of 25 plus 16, right? So that'd be 41. So that's going to be the square root of 41, just using Pythagorean theorem. So that means, again, if I'm looking for cosine of beta, that'd be adjacent over hypotenuse, so that'd be 4 over the square root of 41. And I'm in the fourth quadrant, so cosine's positive, so I can leave that alone. And then if I want to know what sine of beta is, that's opposite of hypotenuse, so that would be 5 over the square root of 41. And I'm in the fourth quadrant where sine is negative, so I put a little negative there. And then I got all of my information there, so now I can just simplify, so that would be -12 over 5 times the square root of 41, and that would be plus, well, the 5s would cancel out, wouldn't they? Well, actually, I don't want to cancel them out because I want to get a common denominator down here, so I'll just go ahead and multiply them straight across. So that would be 20 over 5 times the square root of 41. Right? And so then we can add these together, and we will get 8 over 5 times the square root of 41. And that would be my exact answer to this original question up here. So there you saw we used the sum of difference. Let me do a double angle since we haven't done that yet. So let's say I'm trying to find cosine of 2 beta. So again, I don't know what beta is, I don't know what the angle is, but I do have some information about a triangle that's associated with beta. So I'm using the same given information, right? So first thing I would do is go to the identity sheet and find out another way to write cosine of 2 beta. And notice on the double, let's go look at that actually. On the double angle identities, cosine has some choices there. So this just means that cosine 2 theta could be any one of these. So there's 3 different choices. It doesn't matter which one you pick, whichever one works better for your situation. Sometimes there's not one that's better than the other. So I'm just going to take the first one, cosine squared minus sine squared. So I'm going to rewrite this as cosine of squared of beta minus sine squared of beta. What happened to the 2? You may be asking yourself, well, let's go back and look at it, right? This says that if you have cosine of 2 theta, then you just have thetas there and there. Okay, that's how cosine 2 theta is translated based on this identity. Okay? So now what we have here is something squared minus something else squared, and the first something is cosine of beta. So if I go back up to the triangle, cosine of beta would be 4 over square root of 41, right? 4 over the square root of 41. And it is positive because I'm in the 4th quadrant. And then this one is supposed to be sine of beta, so I go back up to this triangle, and that's 5 over the square root of 41, but we're in the 4th quadrant, so that'd be negative 5 over the square root of 41. In this case, it doesn't really matter because I'm going to square it anyway, so the negative's going to disappear. So here we go. This is going to be 16 over 41, because the square root of 41 squared is 41. And this is going to be 25 over 41. Because again, the negative times the negative would be positive, so that negative doesn't affect this negative, so this one, it just stays minus. So then we have 16 minus 25, over both of them over 41, so that'd be negative 9 over 41. Okay, so there's an example of double angle identity. And you can see that if I would have asked you to calculate the sine, let's say, of alpha over 2, you could go to the half angle identity. And you would plug this into that formula, plus or minus the square root of 1 minus cosine theta all over 2. But now to handle the plus or minus again, we go to alpha. Where is alpha? Alpha is in the 3rd quadrant, but we're taking half of alpha. So if you think about something that's in the 3rd quadrant, in here, if I take half of it, that's going to put it in the 2nd quadrant, because half of pi is pi over 2, and half of 3 pi over 2 is 3 pi over 4, which would be right here. So if you take half of this black section, you end up in the purple section, if that makes sense. Okay. So if we're taking in this case, we're taking the sine of something in the purple section, that's the 2nd quadrant. Sine is positive there, so we can just drop the positive negative. And then we're going to fill in here. This would be the square root of 1 minus, and this is cosine of, in this case, it'd be cosine of alpha, wouldn't it? I made that a little bit thicker, didn't I? Let's go back down there. Okay, so cosine of alpha, we go back up to the alpha triangle. Where is the alpha triangle? Right there. We're in the 3rd quadrant, so it's going to be negative. That would be 4/5. So I'm going to put a negative 4/5 right there, the 2 on the bottom, and then we just simplify this thing. That's going to be 1 plus 4/5 divided by 2. Multiply top and bottom of this fraction by 1/2. So the bottom cancels out, and I get the square root of 1/2 plus 2/5, because the 2 and the 4 cancel. Okay, and of course if you get a common denominator here, this would be 5 over 10 plus 4 over 10, and that ends up giving me the square root of 9/10, which is the same thing as the 3 over the square root of 10. And that would be my answer for sine of half of alpha. All right, so there's some good examples of using the different trig identities to half angle double angle, and sum and difference to evaluate trig functions or trig values. And I will again put some more videos on just doing more examples of this, but that basically kind of gives you ideas, so you should be able to go after the worksheet a little bit.